observations. Suppose that you get 3 observations. Let's say 2, get 2.1, then you get 2.5. Okay. Suppose that there are 3 observations. Okay. Suppose that there are 3 observations, and then you want to estimate the mean value. That is the population mean, and that is what you want to know. What is that population mean? You don't really know that. You don't really know the exact value of the population mean. You don't know it. Okay. You don't know it, but you can get the sample mean, right? What is the sample mean? The sample mean in this case is 2 plus 2.1 plus 2.5 divided by 3, and you get 2.2. Okay. So you may say that the population mean is close to 2.2. Okay, that is what you think. It is true. It is close to 2.2. In order to know whether m is close to 2.2 or not, you need to know the error, right? So let's say I want to know the difference between S bar and n. You don't know the exact difference, but you can estimate it. So basically, you want to find epsilon. If epsilon is big, the approximation is good. If epsilon is small, the approximation is bad. I'm sorry, if epsilon is big, the approximation is bad. And if epsilon is small, the approximation is good, right? And then you can, you want to find the value of epsilon. However, there is no guarantee that this inequality is always true. Why is that? Because you only get 3 observations here, right? You only get 3 observations, and they are random observations. There is a chance that there is a chance, could be a small chance, but there is a chance that the number that you observe are far from the actual means, which makes the difference between the sample mean and the population mean big, correct? Okay. So we want to guarantee that this inequality is always true, but we cannot guarantee that it is always true. So I want to change my my wish a little bit. If I cannot guarantee that it is always true, then I want it to be usually true. Okay? Understand? So I want to find the probability that it is true, and I want it to be high enough. So this value, this probability is gamma, and this gamma is called the confidence level. You call it the confidence level. Okay. And then you can also get, you can also come up with an interval. So in this case, if this is, if you get this gamma and gamma is good enough, let's say 99% or 95%, then you come up with an interval. Let's say x bar minus m less than epsilon, or you can say, oops. Or you can say that m is greater than x bar minus epsilon and less than x bar plus epsilon. Okay. And then you get m belongs to the interval x bar minus epsilon to x bar plus epsilon. All right. Okay. Or you can say m equals x bar plus or minus epsilon. It's just a notation. All right. This is just a notation. Means that m belongs to this interval. This interval is called a confidence interval. Okay, we call it a confidence interval. Is that all clear, everybody? Is that all clear? Is that all clear? All right. Okay, now I want to go back to this. How can we determine epsilon? How can we determine that? If you can find epsilon, you can come up. You can find this interval, right? Okay. So the target of this chapter, is to construct a confidence interval for the population mean. Okay? You want to construct a confidence interval for the population mean. Is that clear, everybody? Is that clear? All right. Okay, there are several cases here. There are several cases. The first case is that x1, xn, they follow a normal distribution with the same mean and the same variance. Okay? And of course, they are independent. All right, why do we need this assumption? The point is that, let's go back to this. If you want to find epsilon, you need to know how to deal with the probability. In order to do that, you need to know the distribution of x bar, right? So you need to know the distribution of the xi somehow. Okay. All right. So let's say if xi follows the same normal distribution m sigma squared, and they are independent, then we knew that h bar minus m over sigma over the square root of n, that follows the standard normal distribution and 0, 1. Okay. In this case, we assume that m is a null because you want to estimate it, right? You don't know it, and sigma square is null. Okay. So if you know h bar minus m over sigma over the square root of n follows the standard normal distribution, then you get gamma is the probability that that h bar minus m less than epsilon. That is the probability that h bar minus m over sigma over the square root of n less than epsilon over sigma over the square root of n. And it is the probability that is z, and you get the absolute value of z less than the right hand side. That is c. Okay. All right. This is gamma again, right? And then you know that c follows the standard normal distribution. Okay, then I'm going to draw the graph of the elastic function of the standard normal distribution. This is minus c. So z is from minus c to c, and this is gamma. So I denote, for convenience, I denote by alpha 1 minus gamma, and the area of the shape equation should be alpha, right? And because the distribution is symmetric, you have two tails, and each tail should be alpha over 2. For example, if gamma is let's say 95%, then this gamma is 95%, then alpha is 0.05, and this is 0.025. Okay. Is that clear? Okay, so what about C? You get C. It points such that the areas to the right is is alpha over 2. In this case, that is 0.025, right? And the areas to the left is 1 minus alpha over 2. And you get 0.975 in this example. All right. Okay. And then what is C, by the way? C is the point such that the areas to the right is 0.025, and we are dealing with the standard normal distribution. So this is simply Z alpha over 2. Okay. Is that all clear, everybody? Okay. So you get that point. You get that point. Okay. All right, and then you can you can get the error, right? Let's say C is the alpha over 2 and you get with that you get epsilon over sigma over the square root of n. Okay? Any questions, everybody? Okay, then you can solve for epsilon to get the alpha over 2 times sigma over the square root of n. Okay? And that gives you the error for the approximation. Is there any question? Everyone? Okay. That is for two sets. You have to set confidence interval, right? Like m is in between x bar minus epsilon and less than x bar plus epsilon. Okay. Sometimes you want to get something like n is less than x bar plus epsilon, right? And you call it the right set. Okay, you call it right set confidence interval. Then you can see that m is less than this. So let's say h bar minus n should be greater than minus epsilon. And you can deal with the probability that this equality is true, and you call it you know it by gamma. Again, you can keep doing that, and you see that with something like this, you have this is gamma. The whole thing is gamma. Including the left tail, you don't have the left tail in this case, right? And the right tail should be alpha, not alpha over 2. And C becomes C alpha, and then I guess epsilon is the alpha times sigma over the square root of n. Okay? Do you understand? All right. So for the two-sided confidence interval, this is what you get. And for a one-sided confidence interval, this is what we get. Okay. The last thing I want to talk about is is how to determine the sample size. Let's say you need the error to be less than epsilon 0, because we can fix gamma and you determine epsilon. But what if epsilon is too big? I mean, it is greater than what you want. So you want to guarantee that the error to be small. If you want, if you have a look at the error, you see that it is z times sigma over the square root of n. Sigma is the population standard deviation, which is the fixed value constant. The alpha over 2 is the point, is the value that can be determined by using the confidence level. So if the confidence level is fixed, then z is fixed. Okay, the only thing that you can change in this expression is n. It means that if you want the error to be small, you need the sample size to be big enough, right? So I need, if I need the error to be less than epsilon 0, then I need z alpha over 2. Suppose that we are dealing with a two-sided confidence interval. Z alpha over 2 times sigma over the square root of n, that is less than epsilon 0. Okay? And then you come up with n is greater than z alpha over 2 times sigma over epsilon 0 squared. And this is the formula we can use to determine the value of n. All right? Is that all clear, everybody? That should be okay, right? Okay, this is an example you can try using the one that I just did. But you can we will do this problem next time. Now there will be a quiz for you, and you can try to solve the problem. All right. It's okay.